15.8, and we'll take a look at 15.7, which is similar, but then hopefully I'll remember to say this twice. The example that I'm showing is a one-tailed test, right? Because we have less than or equal to or greater than is our hypothesis, and your guys' is a two-tailed test, and so that's really only important when we find the critical z value, right? And also how we state our rule, right? So for example, mine's going to be rejective z is greater than 1.645, and yours would be if it's greater than a certain figure or less than a certain figure. Probably do them in the opposite fashion, right? So let's take a look at that now. I mean, both of our significance is 0.05, so when I'm doing the one-tailed test, it's pretty easy, right? I have that same one that I've had before, which is my critical z value is going to be 1.645. But what do I do then if it's a two-tailed? Well, then I gotta divide that 0.05 by 2, right? So I got 0.025. So I'm going to come up here to 97.5 or 47.5, right? See if I can get there. Ooh, look at that right there. So I get a z of 1.96, and I would also have then a negative z of 1.96. So that becomes your critical values, right, and how you look those up. I give you guys too much information. Make this too easy for you. So in any event, so I looked up my z value, and again, it was just like I did. Or just like I said from the prior one. So I can state my decision rules that I'm going to reject, again, based on my alternate hypothesis. I'm going to reject z if it's greater than 1.645. Now, I got one of these nice funky equations here, right? So z is equal to, it's just a long equation. It's really, really simple if you look at it, right? There's nothing complicated at all about the math other than it's long, and so making sure you keep everything together is probably the most important thing. And I also have to say B, right? So I got the decision rule, and then it says compute the pooled proportion. And I'm going to need that, which is called PC. My labeling here wasn't as good as it should have been. So the pooled proportion is basically just my, my x1 or my successes, right? x1 and x2, then divided by my sample sizes, which is n1 and n2. So I've got equal to 70 plus 90 divided by 150 plus 100, and we can do that, equal to x1, x2, so 70 plus 90 parentheses divided by, I gotta have parentheses, n1 plus n2. Boom, so I got 0.64 is my pooled proportion, okay? And then I gotta find my z value, and my z is just p1 minus p2, okay, which is my proportion of 1, which I've calculated here, right? So, and proportion is just simply taking the number of successes, right, divided by the sample size. So my proportion here is 70%, and my proportion here then is 90 divided by 150, or 60%, or 0.6, okay? So I've got that, so the top part's pretty easy to calculate, and that's, again, what I've done here is I've said, well, this is equal to P1 minus P2, so 0.0 or 0.7 minus 0.6. I can do that in my head, but we'll show it here. Okay, and then I do the math here, which is just the PC, or my pooled proportion, times 1 minus my PC divided by n1. Okay, so I think I got these divided into two separate ones, right? So it's simply equal to, I'll just do one of these, so PC, my pooled proportion, okay, times parentheses 1 minus my pooled proportion, and parentheses divided by my n1 in this case, which is 100. Okay? And then I do the same thing for the second part, right? Then I come up with 0.00154, and I got to add those two together before I take the square roots. So simply this is equal to this plus this one, and then I take the square root, right? Because that's what I got to do. So it's just square root of that, and you guys have seen me do the square root. But then I still have to divide the top by the bottom. Yeah, and I put both the tops in Is that fuchsia? Help me out there. I don't know. Anyhow, it's equal to this one divided by this one down here, and one that's a little bit more peach. Ooh, look at that. It comes close to being greater than, but it's not. So I cannot reject the null. Okay, I cannot reject the null. I cannot say that the one is greater than. I can say that that the proportion of 1 may be less than the proportion of 2. Okay, but I cannot say that the proportion of 1 is greater than the proportion of 2. So there you have it. Again, relatively easy math, just kind of long, and make sure you keep your stuff together and you'll do just fine. Thanks for 15-8.